Hello, I'm Kamla. My guest today is Michael Price. He's the Chief Technology Officer of Seismic Warning, a Silicon Valley-based company. And we are going to talk to him about what are the tectonic shifts he has seen in Silicon Valley, because he's worked here for over 30 years. He also worked at Pixar, the iconic film company. Welcome.
Thank you.
So we're going to talk about tectonic shifts, not only physically, but also in the tech area. What brought you from Pittsburgh to Silicon Valley?
I got an opportunity to work in a startup company, and I was thrilled by the chance.
What startup was that?
It's called Valid Logic Systems. It was an electronic design automation company.
Okay. What was it like 30 years ago when you came to Silicon Valley?
It was a transitional state from what was an agricultural early technology, semiconductor, to software, computers.
So Intel probably was the biggest name in town.
Intel and Hewlett-Packard was a big name in town. And there were upcoming companies like Apple, which were attracting a lot of attention. And so there was that transitioning happening. And it was the time where computers were getting inexpensive enough that people could use them for a lot more uses. And a personal computer was about to hit the market. Okay. So it was a big transition, and you could see it throughout the change in the people coming into the valley and the things they were working on.
We'll talk about all those a little later, but first let's talk about what is it that Seismic Warning does. You create some sort of a hardware station?
Yeah, what we do is we place sensors along earthquake faults, the hazardous ones, and detect when an earthquake begins. And then we take that information and provide it to people who are going to be affected by that earthquake to warn them that an earthquake has begun, it's going to affect them, here's the level of shaking they're going to see, and give them some time to do something ahead of the arrival of the shock waves. Okay.
So this is all around California or just Silicon Valley that you've got your sensors?
The plan is to do it throughout the state. We've got a project started in Imperial County, and we'll be starting a project here in the Bay Area.
Okay, so let's first look at the earthquake itself. When an earthquake occurs, what happens?
Earthquake is a rupture in a crack in the crust. And when it breaks, it causes shock waves. There are two. One is a fast wave called a primary wave. It's like a sound wave. And a second is a secondary wave. But most of the energy is in the second wave, which is about, it's not quite half as fast. So if you can detect that in a primary wave, and you're able to understand what that primary wave represents, you can predict how big the S wave is going to be.
So there's a lag between the primary wave and the secondary wave.
Right.
And primary wave travels faster, you said?
Yes.
So what does that lag between the P and the S wave indicate to you, or how do you analyze that lag?
Yeah, we don't look at the lag, we look at the P wave itself.
Oh,
and we can
okay.
deduce from the character of the P wave what the S wave will look like.
When you say character, what are you looking for? What are the characteristics of a P wave?
It's rise time, its dominant frequencies, how much displacement there is indicated by it, and those kinds of parameters. And that allows you to tell people before the S wave arrives what the S wave will look like. The key is doing that quickly enough that you can actually complete that analysis and give people a warning before the S wave arrives, which is easy if the epicenter is 100 kilometers away. It's difficult if you're at the epicenter.
Why is it difficult if you're at the epicenter?
Because if you're at the epicenter, the distance between you and the earthquake is, you're right at the epicenter. The epicenter is maybe 8 kilometers deep, which is the average depth for California. The time difference between the arrival of the P wave at the surface and the arrival of the S wave is about a second.
That's it?
That's it. So in order to provide a warning for people at the epicenter, you've got to be able to detect the P wave, analyze it, and distribute a warning in less than a second. Now, you're not going to have people respond in less than a second, but there's lots of automated systems, control, put them in safe mode, shut off electricity and power, that you can do very quickly, even at the epicenter with a few hundred milliseconds of warning.
So people living outside of the epicenter would get better warning than those who are in the epicenter?
Right.
Okay. So what is it that you have created? Is there a product that you've created that people can use or enterprises can use?
We started by building a device which we would install in a facility to protect just that facility. We had them in the fire stations in Vallejo during the South Napa earthquake.
2 years ago.
2 years ago.
Okay.
And we've had them in Southern California for starting in 2001. And we have them, there's some in El Camino Hospital, and Lawrence Berkeley Labs has a system and so on. And that protects a single facility. But they have to put sensors there, and that's a lot of cost, which you really don't need. Once you get enough sensors in a region, you can detect all the epicenters, and then you can just send a signal over the internet, for example. So what we're doing is building a network of sensors, and then from that network we produce a signal which we'll sell to individuals as like a subscription. So what you'll have in your facility is a box which receives the signal to control a door or turn on some lights or shut down some equipment or provide an audio alert. And we will then send a signal to that from our system. So first we deploy the network, and then we can offer a subscription service to people to get the warning.
So you had, I'm guessing that you had a chance to see what happened in the South Napa earthquake. What is it that you ended up learning from deploying your product?
Well, the systems in Vallejo are very close to the epicenter.
Oh.
And so they got about 2 seconds of warning. The new system will produce about 4 seconds of warning, which doesn't sound like a lot. But if you look at other systems and what they would have done or did in that earthquake, they weren't able to provide a warning before the shock waves hit any of the places where buildings were badly damaged. So if you look in Napa and you look in Vallejo, there are a lot of buildings were red tagged, which means they're essentially not occupiable. And other systems were so slow that they couldn't have gotten a warning to those locations before the earthquake struck. So what we learned there was that our system works very well near the epicenter. This is not the first time that we've learned that. And those systems were installed in 2002 and 2003. So they've been sitting there for 10 years, not producing false positives from all the trains and trucks and other things that are driving by. So it was a validation of the technology that is going into our next generation product.
You mentioned other systems. So you are a private company or a startup, you've got funding. What are these other systems that you're talking about? Is that the state?
The USGS is working on a research project which they'd like to turn into an operating earthquake warning system. Japan has a system, a national system that uses a very large array of sensors. They were operating during the Tohoku earthquake in 2011. Those systems work on basically the same principles, but ours works on a different principle because we want to eliminate blind zones. We want to be able to provide a warning to people who live in Hayward if there's an earthquake on the Hayward Fault, and not just provide warning to people of Hayward if there's an earthquake up in Mendocino.
Gotcha.
And when the earthquake's far away, it's easy to be able to provide a warning because you have lots of time before the S wave arrives. But if you're at the epicenter or near the epicenter, you don't have that kind of time. And in California, we build our cities on earthquake faults, so it's important that we can protect that.
Entire Silicon Valley region is on earthquake faults. How many faults are there in this neighborhood if you look at the Bay Area?
There's a lot of faults, but the three primary ones are the San Andreas, which is along the peninsula, the Hayward Fault, which runs along the East Bay, and the Calaveras, which is just over the hills to the east of that.
Which is where the water supply is.
Yes.
Calaveras. Ever since, probably you saw the 1989 earthquake.
Yes.
What was that like, the Loma Prieta?
Well, I was in San Rafael, so it's pretty far north.
Working for Pixar?
Working for Pixar.
Okay.
And it was a sharp jolt, and it shook the building. It was a very unusual earthquake because the epicenter was down by Santa Cruz. We forget that downtown Santa Cruz was pretty much obliterated by the earthquake. We tend to focus on Oakland and San Francisco, the marina. There's not a lot of damage in between, however, and because...
When you say in between from Santa Cruz to, all the way up to the San Francisco,
right,
the peninsula.
The peninsula, it was shaking, but you didn't see a lot of damage there.
Why was that?
It's because the shock waves traveled through the bay in such a way as they were mainly underground, and they came back up to the surface.
Oh, so you're saying the bay, so they came from the ocean to the bay, and so they didn't travel along the coast.
No, they traveled through the rock. And so they're up in the hills, the Santa Cruz Mountains, and they spread out from there, but they reflected off a basement layer of rock in the bay, because the bay is really just a lot of alluvial deposits, but down below there's some bedrock.
So Milpitas would have felt something.
Felt something.
Okay.
But the shock waves are sort of passing it by, because it was a 6.9, and the further you are from the epicenter, the less the shaking there is. That's normally the case. So you wouldn't expect there to be a great shaking in San Francisco. However, the shock waves came back up to the surface and concentrated up in San Francisco and across the bay in Oakland. And they'd say a lot more shaking there than other regions did that were closer to the earthquake.
So is that why the marina was particularly impacted, because it's at the tip of the bay in a sense?
That's part of it. The other part of it is that it's built on landfill.
Landfill, right.
Ironically, landfill from the 1906 earthquake.
Oh, really?
Yeah. So they took all the debris from 1906, they put it in the bay, built the marina on top of it, and then in lower period, that shook, it liquefied, the building collapsed. So don't build on fill, certainly don't build on fill.
But they rebuilt the marina.
Well, yeah,
and it's a hip and happening place.
It's a great place to live when there's no earthquakes.
Yeah, because you have this beautiful view of,
right.
the Golden Gate Bridge and, across Marin County, the headlands and everything. So you felt the earthquake in '89, and how did you get back home then? Because the Bay Bridge collapsed.
I took the Golden Gate. It turns out that was the fastest route, I thought, because I could go along the coast, like down Highway 1 if I had to, where if I would try to get across the Bay Bridge, you have to go through Oakland. There's a lot of people, a lot of traffic, a lot of potential damage. So I raced across over to 101, came across the Golden Gate. They closed it right after I passed by. 19th Avenue was completely deadlocked, so I went over to, down to the beach,
right,
up to Daly City, drove past the Daly City overpass had collapsed, and snuck onto 280. And
the overpass had collapsed.
Yeah, and then I just happened to get just lucky to get past all that, and then just drove down 280, and there wasn't a lot of traffic on 280. A lot of people were stuck in traffic in various places trying to get out.
So now that you're working for a company that makes these equipment to warn you of earthquakes, how have you reconfigured how you get information and how you yourself and you and your family would be prepared should an earthquake occur?
If you're in the earthquake business, you tend to be a lot more cognizant of the risk that you're facing. So I think in general, people in the company are a lot better prepared on average. They have potable water stored up and food stocks. And
Do you have that?
Yes.
In your car?
In the car, in the house, in two places. Everything is earthquake strapped down, and all the cabinets have locks on them, and so on and so forth, because it's going to happen, and you want to be prepared. And I've earthquake retrofitted my house, which was built in 1935, so it's structurally not very modern. And so you've spent some money upgrading that so it won't fall off the foundation in an earthquake.
So what do you have with you in terms of earthquake preparedness in your car? You have water, food. Do you have any cash?
I don't have any cash in my car, no.
Medicine?
I have first aid kits, yes.
Okay.
A little bit of food, stuff that won't won't spoil, so it has long shelf life stuff.
Okay. What brought you to this company? You've had a very interesting career, and what prompted you to join this company? The
earthquake warning is a really exciting business, because what you're doing is building a product that could potentially save lives. It's important in a way that lots of products aren't, and so you come there with a mission to say, if I can take my skills to design something which will protect people from a hazard which they've always faced but felt that there was really nothing they could do about it, it's really rewarding. And when you go and talk to people and say, we can protect you from earthquakes by giving you a warning which allow you to take some action. First off, they're amazed that it was possible, but now it's a lot more, there's a lot more awareness of it than there used to be. But also they're just anxious to get it, because they want to know that when an earthquake happens, they can at least do something, and we can provide that. And it also has a huge impact on the resilience of the economy, because the biggest benefit of the product is that it reduces business interruption.
That's right.
Which means the economy gets back up to running faster, which means everybody benefits, and so it's good for people, it's good for life safety, it's good for the society, because we're helping the economy be more resilient for earthquakes, which are inevitable. So.
Let's go back to growing up in Pittsburgh. How did you get interested in math and science?
I think it is an aptitude. I think it was easy for me. I was a lot more interested in challenging myself on other ways than math and science, so I just sort of coasted through school on math and science. So got interested in photography and art and that kind of thing because those things were challenging. Because I didn't feel I had an innate ability for them. But
photography.
For photography, for example.
But for math and science, it was a breeze.
It was a breeze, right?
Okay.
And at schools I didn't have a lot of AP courses, so it was just, sort of standard curriculum, and it was okay.
Your dad was an engineer.
Yes, and so was my grandfather.
Oh, your grandfather also. What kind of an engineer was your grandfather?
He was in the steel business.
Okay, so you're third generation engineer.
Yes.
So maybe the aptitude was there. You had mentioned before the interview that your grandfather gave you a wristwatch when you were 5 years old?
Yes, he came out, he lived in Colorado, we were in Pennsylvania. He came out for my birthday and gave me a wristwatch, which was a wonderful gift. I was thrilled by it. I was 5 years old, so I really didn't have any need to tell the time. And the first opportunity I got, I took it down in the basement and said, well, how does this work? There's a thing.
Do you remember that?
Yes, I remember very distinctly because it was a big deal. I had this thing on my wrist, and the little second hand would tick away, and the minute hand would move, and I said, well, how is it doing that? Not that I really understood what the significance was, so I got my dad's jeweler screwdrivers out and I took it apart. And
you knew how to use a screwdriver and everything?
Yeah.
So you're saying, did somebody teach you, or did you have an aptitude?
It's just something you play with. I mean, I just sort of played with them. To me, they were toys like anything else, and so I just learned how to use them. And
your mom never said, don't play with it?
She got frustrated when I would find a screw and I would unscrew it just to see what would happen. And sometimes nothing happened, and sometimes it would fall down. And so you pry the back off the wristwatch, and what you see is lots of really cool little parts, gears and movements, and the escarpment was going tick, 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 tick. And I said, I got to see how this works. So I took it entirely apart, and it was just spread out in little parts all over the desk. And when my grandfather saw that, he was so mad. And I think that's why I remember this event so much. He was so mad.
Why?
I had destroyed his birthday present, and I hadn't had it for more than an hour or two. But my father came by, and he looked at it and says, okay, well, you should put it back together. And so I thought about that, and I put it back together. It didn't work, but I was proud that I got all the parts back in. I thought that was good enough, and it didn't work. And my grandfather was totally disgusted with the whole thing. My dad said, "Okay, yeah, that's fine."
So I guess it's not surprising that you went on to study engineering at Carnegie Mellon.
Right.
And electrical engineering, was that a new field at that point?
No, it was an old field. It was actually trying to transition into computer engineering at that time. So it was sort of in the middle.
But Carnegie at that time was probably one of the best engineering schools.
Really good engineering school. It had a very, very good graduate computer science department even then. And so they didn't have an undergraduate computer degree. So you had to go into EE if you were interested in computer science, but they had a computer science as well as EE graduate program.
So you worked on computers then?
I was very fascinated by computers, and they were very much into that kind of technology.
Punch cards?
Unfortunately, yes.
Oh.
Paper tape, and it was primitive. Of course, you sit around the table and say, well, yeah, I did punch cards. Well, I did Mylar tape, and, who could be more primitive than somebody else?
So did you also study at Stanford?
I took some master courses there, but I never got a degree.
Okay, yeah. So then you moved to Silicon Valley, and then you worked, like you said, for an EDA company. What I'm fascinated about is your stint at Pixar. You joined Pixar in the 80s. When was it making movies then? What was it doing at that time?
It was building a device called the Pixar image computer, which was a purpose-built attached processor for like a Sun workstation or a VAX station, which was a popular computer back then, which is from Digital Equipment Corporation. And it would render 3D images. This could be used for rendering a 3D, like you see today, CGI. Back then it was photorealistic rendering we're doing. Or it could render databases like MRI data. And one of the things they did was volume rendering, which is rendering a 3D model of a point cloud of data you get from an MRI, so that the physicians could see what the organs looked like and they could rotate it and so on. And that was a very specialized kind of a computer to get the performance to be able to do this in some kind of reasonable amount of time. So that was the hardware selling. They were selling a 3D rendering software, which is used in movie production for people trying to do early photorealistic rendering. And then to hone their abilities to do the technology and to advertise what they were doing. They had a group that was doing 3D animated short films. And these were, they weren't money-making films, but they were released as a marketing tool and also as an R&D tool. And they won an Academy Award for Tin Toy.
Were you there at that time when it won an Academy Award?
No, I started right after that.
Okay.
So John Lasseter was the creative mind behind that. And what you had was a very interesting collaboration between some engineers who were writing software and writing tools for an animator to manipulate 3D objects, which is actually a hard problem, to do it in a natural fashion. And then you had the artist, Lasseter, saying, here, I want this object to move like this, and I want to be able to articulate like that. Give me some help here. And so it was this constant back and forth, and as a result, they were able to produce some wonderful technology and some wonderful films.
So it was, were you there when the Luxo, he made that film on Luxo Jr.?
No, that was also before. So I was there when they did Tin Toy, and then they did Knick Knack.
Okay.
And after Knick Knack, which is their first 3D film, it was thought that maybe we should figure out how to use some of this animation skill to make a little bit of money. So we were, they started doing some commercials and this kind of thing, but they then approached Disney and to do a film, a full-length feature film. It was the first 3D animated film, and John Lasseter this had been one of his desires for a long time to do this, and so they started working with Disney on their normal cell animated paint process, which got them in the door on the technology, and finally made a good pitch on the vision for a 3D film, and then they got a contract. And the rest is history, as they say.
So you got an opportunity to work with Steve Jobs then?
Yeah, so Steve owned Pixar, and the team at Pixar was fairly small. And so we
How small?
Oh, the company was maybe 30 people. And so we met with Steve periodically, because he was very interested in Pixar. He wasn't trying to make money. I mean, he would have happy for it to make lots of money, but at that point, it was really shedding technology for other things. A lot of it went into Next Computer. A lot of that eventually went into Apple when Steve returned to Apple, and a lot of other technology we just published and let people go with it and use it for their own purposes. Plus the products that we were trying to make. So we met with Steve a lot. He wanted to know how things are going. He had suggestions on where we should do and we should go next and how we should apply it. He came up and visited with the animators because he really liked the film work that was going on. And so he was involved not on a day-to-day basis, but he was frequently in touch with us.
What was he like to be in a meeting with? How did he conduct his meeting?
It was very, what should I say? He had a lot of creative energy, a lot of insights into what was important. Not technical insights, but what you're doing is important because what you're making possible for other people to do. That's why the relationship with Lasseter was so interesting, because he saw technology in service of an artist, an animator. And he was interested in the technology, but was much more interested in what the animator wanted and needed to be able to do the best kind of animation. And so he was constantly talking about what he thought we could do next and how we could improve on providing these, the end user, the artists, something that would allow them to do something totally new and different. Plus, he really invested in Pixar, I think, altruistically, because there were a lot of technology the company had developed that it just let people use. There was the volume rendering was this voxel idea of taking a point cloud and turning it into a 3D object. That was a patent that they had, and they didn't defend it.
I've never heard the word altruistic used in conjunction with Steve Jobs.
I haven't either, but I was amazed because it was present in a lot of the conversations we had during that era of Pixar.
Okay,
yeah.
And so when Pixar became, I guess, successful, he must have been a happy camper.
No, he was a very happy camper. Yeah. He put a lot of money into Pixar, and it seemed like at some point there that maybe this was a bad idea in retrospect, but then, of course, it turned around.
Okay, so we have a few minutes left. After Pixar, you joined a Creative Lab?
Yes, Electronic Music Instruments division of Creative Lab, which was called EMU Systems.
What did you learn from working with Electronic Lab? Because that's an audio, they made Sound Blaster, and they made the MP3 player. Creative Labs.
Creative Labs did those. What we did is we made instruments for musicians.
Okay.
We also did instruments and audio processing units for movie post-production people. And what we're serving were people who were creating or sounds, or they were creating music. And so what we're trying to do there is give the musician something that expresses their musical, their musical insights or their musical vision using technology. And so it was an entirely different customer and an entirely different application. And a lot of the people in the company were musicians because you want people to have some insight into your end user. So it wasn't serving an engineering customer, it was serving a musician, just like we were serving artists and animators at Pixar. So it was a really nice opportunity to find another community of people who had an artistic vision they wanted to produce, and they wanted some tools that allow them to do it using the power of modern technology, and that's what we did.
When you were studying engineering in Pittsburgh, did you ever think that one day you would work at Pixar or a company like Seismic Warning? What did you think you would, where do you think you'd be working? I
had no idea. I was interested in learning, how to do this craft and learning how to build the things that I, saw around me. I just wanted to participate in that. And I had really no idea where it would end up. And so for a few years, it was sort of blow where the winds took me kind of thing. But once you get into the business and you realize a little bit better how things work and how companies are interested and not interested in certain things, then you realize that you can direct your career in one direction or another. So I've been I stick around in a particular market for a while, then I say, okay, I've understood this, I like it. Let's try something new, try a different set of end users and customers you're trying to serve with technology and see what they tell you about what you can, how you can contribute and what you can do with your skills.
If there's a young person out there who has an aptitude for math and science, what do you recommend they should do? Because you said you didn't know what you wanted to do once you graduated from school. In hindsight, what recommendation or advice would you give somebody who is young with a strong aptitude for math and science? And
if you've got an aptitude for math and science, then what I did is I accidentally, as it turns out, learned how to solve problems, how to apply that, and to recognize that somebody has a problem, and using your skills, how to turn that into a solution. That's a general case kind of a knowledge. I learned programming languages. I learned how to design in TTL, which is a completely obsolete technology. Those things were good for a few years, but then there's something else you have to learn. What's really important is to be able to synthesize a solution to a problem by understanding what people want out of it. And if you can build that skill, then you can take your abilities and do lots of different things with them. But if you think of yourself as a tradesman where I got to have a toolbox, I know JavaScript, I can do React.js or whatever it is, then you're really limiting your horizons. Don't do that.
Michael, thank you so much for sharing what you learned as an engineer. Problem solving is the key, skill that you need to have.
Thank you.
Thank you. And thank you for watching. If you missed any of our show, you can watch them on our YouTube channel. We'll be back again with another edition. Until then, goodbye.